So the big picture for this lesson is scheduling tasks. And here I have a directed graph and a schedule, and I just want to briefly explain some of the features. So the directed graph, that starts on the left with task 1 and task 3. And it shows that these two tasks are going to be happening first. And there are two different branches, which means these tasks could be running at the same time. And then task 2 follows task 1, and there's an arrow pointing to it. That means task 2 must wait for task 1 to finish before it can start. And then task 4, same thing, waiting for task 3 before it can start. And then task 5 has to wait for both 2 and 4. And then 6 and 7 each wait for the tasks that come before those. So let's look at the schedule and how that relates. So starting with task 1 here, first processor, that's you, and in this case the scenario is getting ready for school. And then your parent is the other processor who can do some things to help you get ready. And you can see task 1 and task 3 both starting at time equals 0. The times are down here at the bottom. And then at 10 minutes when task 3 ends, task 4 can start. And then when task 1 finishes, task 2 can start. And when both of those are finished, task 5 starts, and then 6, and then 7. And notice the times are all indicated along the bottom here to show how much time it takes to complete each task and how far along you are in the overall schedule. So one thing you're going to be doing in this lesson is looking at order requirement diagraphs like this, and then determining which schedules can match to that graph. And it's all about waiting for others to complete before starting, and also just the order of tasks in general. The other item in this lesson is called the list process algorithm. What you're doing there is using a priority list to make a schedule of tasks. And basically it's all based on using the priority list, and there are videos in the lesson that explain that. So that's the big picture for this lesson.